guys, welcome back to the channel. My name is Jag, and in today's class we are going to continue with our Chemistry 11 content, and we're going to move on to determining the formula of a hydrate. So with that, let's get started. I'm going to read the question out loud, and then we will again write down all the values that are given on the board, and let's solve this question together. Okay? So a hydrate of barium hydroxide is used to make barium salts and to prepare certain organic compounds. Since it reacts with carbon dioxide from the air to yield barium carbonate, it must be stored in tightly stoppered bottles. So again, basically, I have some molecules of water that are attached to this barium hydroxide compound. Okay, so let's try part A here. Okay, so A says a 50-gram sample of the hydrate contains 27.2 grams of barium hydroxide, and calculate the percent by mass of water in the barium hydroxide compound. Okay, so it's actually the barium hydroxide compound, and I don't know how many molecules of water there is. Okay, but for part A, we're just looking for basically the percentage of water. Okay, so let's put percent of water. I have the total sample, which is 50 grams. And I'm going to subtract the amount of barium hydroxide. It gives you the mass of barium hydroxide is 27.2. We're going to divide it by the total sample mass and times that by 100%. Okay, so again, just put it into your calculator. Let's make sure we're getting the right answer. So 22.8. Okay, so let's write maybe like one step here. Divided by 50. And times 100%. Again, make sure you are writing your answers going down here. Okay, and we are getting 45.6% is the percent by mass of water, okay, within this compound where water molecules are basically attached to the barium hydroxide compound. Okay, so that's it for part A. Okay, so what's really important is basically part B here. So part B says find the value of X in the barium hydroxide XH2O compounds. Okay, I'm going to just take off part of this. Okay, so I'm going to put B here now. So I'm going to leave the formula up there. Okay, so what we're looking for is just this value of X. Okay, so what we're going to do, okay, is let's start off with the barium hydroxide. And I have to find basically the moles of barium hydroxide. Okay, and again, remember when you're looking for the moles, it's going to be the mass divided by the molar mass. Okay, again, make sure you are using the periodic table to look for the molar mass, okay, for barium hydroxide. And again, we will write it out here, okay, so everyone can see. Okay, so if I'm looking in the periodic table here, okay, barium is 137. So I'm going to write it on the bottom here, okay, so 137. Oxygen is 16 times 2. Okay, and remember, because there are brackets here, okay, outside the brackets is a 2, so 2 atoms of oxygen, okay, and then there are 2 atoms of hydrogen. Okay, so it's basically just like this. And again, if you want, you can actually do it in 2 steps here, right? So we can just leave that on the bottom. Okay, I have the mass of barium hydroxide, so it's 27.2. Okay, so we're just gonna double check. Okay, we're gonna double check just the molar mass here, okay, for barium hydroxide. And we're getting 171, okay, is what we're gonna round that to. Okay, and I'm just going to put the equal sign here, and we're going to find the number of moles. And again, I like to round the number of moles to 4 decimal places to make sure it's very accurate until the end. So we're going to put 1591, okay, moles. So this is basically the moles for barium hydroxide. Then I also have to find the moles for water. Okay, so let's write it over here. So I'll put moles of water. Okay, and again, I'm going to do the mass divided by the molar mass. Okay, and we'll do the mass of water. So I'm doing 50 minus 27.2, which is 22.8. Okay, and the mass of water, you're going to do 1 times 2 for hydrogen. Okay, and remember oxygen is 16. If you don't remember, just check the periodic table. Okay, so we are going to divide 22.8 divided by 18. So I'm going to put 1.267. Oh, let's put 2667. Okay, so I want to keep it again to just like 4 decimal places. Okay, and it makes like a difference at the very end, especially when you are rounding. Okay, so basically we have our 2 moles here. Okay, I have the moles of water and the moles for barium hydroxide. So this is actually very similar to the empirical formula. I look at both of my numbers here, and I'm going to divide by the smallest number. Okay, and I can see the 0.1591 is smaller here. Okay, and that's what we're going to divide both of them by. Okay, so I'm going to put over 0.1591, which is equal to 1. Okay, and the same thing here, I'm going to do divided by 0.1591. Okay, and we'll just write the equal sign there. So 2667 divided by 0.1591. Okay, and we're getting basically a 7.9, and we can round that to 8. Okay, does everyone see that? Okay, so basically that's going to be our formula here. So the formula is going to be barium hydroxide. So whatever the compound is here, it's always going to be 1 for the compound. I'm actually just looking for the number of water molecules. So in this case, it's going to be 8. So times 8 molecules of water. Okay, and that's all you're looking for. It just says find the value of X in this compound of barium hydroxide times X number of water molecules. Okay, and that's how you're solving it. It's just like the empirical formula again. Okay, you're just going to divide it by the smallest number of moles, and that gives you the smallest whole number ratio, okay, for that compound. Okay, are there any questions here? Okay, yeah. So this is basically how you are doing the formula of a hydrate. Okay, I can also find basically the percent by mass, okay, of water within the compound as well. Okay, and it will always give you the mass, okay, of the actual compound itself. Okay, so let's try basically one more example with that. Okay, so I'm going to take this off. Okay, and let's try an example that's similar to this. Okay, so again, I'm going to just read it out loud. You have a 3.34 gram sample of a hydrate, has the formula strontium. Okay, this is strontium S2O3 times X number of water molecules. Okay, and it contains 2.3 grams of strontium S2O3. Okay, so it is 2.30 grams. Okay, and I'm going to put mass of the sample. Okay, again, this is just so we can see all the values here. The mass of the sample is 3.34 grams. Okay, and find again, we're looking for the value of X. Okay, and so say I'm looking for the value of X here. Okay, I have the strontium S2O3. Okay, so again, we're just going to look at the periodic table to do the moles. So I'll put moles, okay? And it's going to, let's put the equal sign, okay? So mass over the molar mass. Okay, and the mass of the actual compound is given. It's 2.3, okay, or 2.30. And we're going to add strontium is 88. And this is the molar mass, okay? Sulfur is 32. I'm going to do 32 times 2. Oxygen is 16, and I see there are 3 atoms of oxygen, so 16 times 3. Okay, and make sure you're adding the molar mass together here, okay? I'm just going to put it into my calculator. Okay, so 48, we're gonna add that, 88. Okay, so we're getting the molar mass as 200. Okay, so 2.3 divided by 200, 0.0115 moles. Okay, so these are the moles of the compound. Okay, just like in the other question, we're going to do the moles of water again. Okay, the mass divided by the molar mass. So when you're looking for the mass of water, okay, you take the mass of the sample, so 3.34 minus 2.30, so 1.04, and the molar mass for water is 18. Okay, so you don't need to always show your work for the molar mass. Again, just check with your teacher, and some teachers are okay with it because water is a molecule that's used all the time. Okay, let's put 0.0578 moles, okay, of water. All right, yeah, so we have the moles of water and we have the moles of the compound. I'm looking at both of the moles here. I'm going to divide it by the smallest number of moles. Okay, so I can see right here it's going to be the 0.0115. So again, the compound is always going to be like 1 mole as the coefficient. Okay, and then do the same thing for water. So 0.0115. Okay, and it's okay because we are rounding the numbers here, and I'm getting 5. Okay, so it's exactly 5.0. Okay, when you divide these compounds and you're looking for the moles of water, okay, in most cases it will give you a whole number. Okay, but again, remember, if it's just like an empirical formula, if you see that it's like a decimal and the decimal is not close to the whole number at all, so like it's like 5.3 or 5.4, I can't just round that number. Okay, again, I'd have to multiply both the numbers by 2 or 3 until I get that even number. Okay, but in most cases you should get the even number right away because it gives you the number of water molecules in the whole number ratios here. Okay, so let's write our answer here. So therefore it's SR S2O3, and I'm going to put the dot. Okay, and there are 5 molecules of water that are attached, okay, to this compound. And that's how you're finding the formula of the hydrate. Okay, so one more time, it'll give you the mass of the sample, and then it will give you the mass of the compound. Okay, to find the mass of water, I'm just subtracting the two numbers. I'm looking for the moles for the compound as well as for water. How I do that is by putting it into the formula for mass divided by the molar mass. As soon as I get the 2 moles, just like the empirical formula, I'm looking at which one is the smallest number of moles. I'm going to divide by those by the smallest number, and that gives me the whole number ratio for the number of water molecules. Okay, so that brings this video to an end if there are no questions. And today we covered chemistry 11, how to calculate the formula of a hydrate, and it's just like the empirical formula, so you can see that it's very simple. So thank you for watching this video. If you like the content, please make sure you're subscribing to the channel and click on the like button below, and I will see everyone next time. Thanks, bye.